Chapter 1 Introduction to this book. Section 1.1 What is statistics and why learn it? When I took my first statistics course at university, we called it sadistics. Many students complained about the course. I went along and joked about it, although it was because I was socially awkward and trying to fit in. The truth is that I enjoyed the course, and I didn't find it as impossible to comprehend as other people had claimed. I couldn't figure out whether they really hated the course or whether each person had the same internal experience that I had, secretly enjoying it but feeling socially compelled to kvetch. I won't be so audacious as to assume your experience reading this book, but I hope it's closer to my university stats experience than to that purported by my Stats 101 colleagues. Statistics is about using data to help make decisions in the face of uncertainty. Sometimes the uncertainty is so small that you don't need statistics. For example, what's bigger, the Earth or the Moon? Definitely don't need statistics to answer that question. Here's another one. Do women gossip more than men? Well, certainly there are cultural stereotypes that proffer an answer, but I'm sure you know gossipy men and tight-lipped women. So to answer this question in general, we would need to gather data and we would need to perform statistics on those data. But what does it mean to perform statistics on data? Statistics is a broad set of algorithms for transforming numerical data into a small set of interpretable values that describe the world and our certainty about interpreting the world. See figure 1.1. If you're not looking at this figure depicts three different panels. The leftmost panel is titled Data. It shows a collection of gray squares, and the text underneath says harder to interpret. The middle panel is an abstracted funnel and has the word statistics printed on top. And then the rightmost panel has a star with results printed on top, and underneath it says easier to interpret. The figure caption says, statistics is a set of algorithms that acts like a funnel to transform numerical representations of the world, which are data, into a small number of results that can help guide decision-making. Back to the text. Many statistical procedures ultimately produce a p-value, where the p stands for probability. P-values have a nuanced interpretation that you'll learn about later in the book, but basically it's the probability that an effect you observed in the data was actually due to chance and not to a real effect. P-values close to zero mean that the pattern in the data is less likely to be a chance occurrence. Thus, the smaller the p-value, the more we believe in the effect. And conversely, if the p-value is closer to 1, then we decide that any apparent effect is just due to a chance occurrence and is unlikely to be observed in a repetition or replication. Statistics plays a crucial role in myriad areas of human life, ranging from quantum mechanics to medicine to financial retirement planning. Companies, large and small, from Amazon down to a one-person startup, are increasingly using data to guide their decision-making and business strategies. Therefore, understanding how to process, analyze, visualize, and interpret data is increasingly important for an increasing number of professions. Section 1.2, Statistics, Data Science, Machine Learning, etc. What are the differences among these terms? Are they really different from each other? In a broad sense, no, the different terms are just rebranding of the same procedures. I think we can agree that data science sounds intriguing and fresh. Machine learning sounds futuristic and sci-fi. Business analytics sounds serious and competitive. In contrast, statistics sounds old, dry, mathematical, and tedious. So In this broad sense, all of these terms share the common goal of taking data as input, applying some algorithm or set of algorithms, and providing interpretable values as output, which we then use to help us make decisions and understand the world. But there are some subtle yet meaningful distinctions that are worth mentioning. So, with regards to statistics, Wikipedia provides a solid definition. Quote, "The discipline that concerns the collection, organization, analysis, interpretation, and presentation of data." End quote. Most of the content of this book fits well with that definition. Footnote, I politely disagree that statistics includes data collection, but the rest of the definition seems uncontentious. End footnote. Now about machine learning. Although often used interchangeably and using the same analyses, machine learning and statistics have slightly different goals. The goal of inferential statistics is to make population inferences based on sample data, whereas the goal of machine learning is to use patterns in the data to predict or classify an outcome. There are many situations where statistics and machine learning use the same analyses and algorithms, but the researcher would focus on different aspects of those analyses. For example, both statistics and machine learning use an analysis technique called regression, but the statistician will focus on the statistical significance and interpretation of individual regressors, while the machine learning professional will focus on the accuracy with which the model can classify data samples. If you struggle to understand this distinction, then don't worry about it. You need to understand more about statistics and machine learning for it to make sense. We will return to this discussion later in the book. The point is that the similarities between statistics and machine learning overshadow their differences, and many of the disparities involve the interpretation of final outcomes rather than fundamental divergences in the underlying mathematics or code implementations. Now about data science. Different people have different opinions on whether and how data science differs from statistics. I have no strong opinion on the matter, but it does seem that data science is more focused on modern applications and includes types of data that traditional statistics has largely ignored, including images and time series and text. Now, I must admit that attaching the word science irks me a bit. Science means trying to understand something for the sake of understanding it. But data science is not really about the science of data. It's about using data to help make decisions. You can use data to make better decisions without really understanding the data. And perhaps this is part of the reason why the term data engineering has also been floated around. Now about data mining, analytics, informatics, omics, etc. Without sounding condescending, I'm sure there are valid reasons for inventing this menagerie of terms. And I'm sure there are domain-specific nuances that justify using any of these other terms instead of statistics. But that is not a level of subtlety that I am willing to spend any time on. The point of this discussion is that although, for example, statistics and machine learning are perhaps not identical disciplines, they overlap enough that this book will give you a solid foundation for any of these specific terms your future employers will use in your job description. Section 1.3, Target Audience. I wrote this book with the self-studying reader in mind. Perhaps you did not realize that you needed to know statistics while you were in university. Or perhaps you're currently in a university course, but are not satisfied with the recommended course book. Indeed, many statistics textbooks are densely mathematical and therefore intimidating to non-math students. Or maybe these textbooks were written before personal computers were popular and powerful, and therefore they were once great textbooks, but they are no longer relevant. I hope that this book is a useful resource inside or outside a formal course. Margin note: you are the master of your education, and you should see this book as a guide to help you navigate your adventures, not as a sacred text that must be followed exactly and in order. End margin note. Many extant statistics textbooks are heavily math-oriented, with a strong focus on abstract concepts as opposed to practical implementations. I don't write this as a criticism. Pure statistics is a rich and intellectually challenging topic that forms the basis for applied statistics. But for those interested in using statistics as a tool to understand data and using data to help make decisions, exclusively mathematical treatments of statistics can be difficult or impossible to learn from. So my goal here is to present applied statistics in an approachable and comprehensible way, with a strong focus on concepts that have a clear link to implementations, applications, and interpretations. Section 1.4, Prerequisites. The obvious. Dare I say it? You need to be motivated to learn statistics. Statistics is not so difficult, but it's also not so easy. An intention to learn and a willingness to dedicate time and mental energy towards that goal are the most important prerequisites. The following points are minor in comparison. So, concerning high school math, you do need to be comfortable with arithmetic and basic algebra. Can you solve for x in the equation 4x squared equals 9? If so, you have enough algebra knowledge to continue. Other concepts will be introduced as the need arises. There are formulas, equations, and algorithms in this book, but I tried to explain them in plain English, illustrate them with graphs and diagrams, and provide you with Python and R code so that you can explore the math through simulations and visualizations. Concerning calculus and linear algebra, none. That said, statistics is a branch of mathematics, and so the more familiar you are with other branches of mathematics, the easier it will be to learn statistics. This is a book on applied statistics, not pure mathematical statistics, and so I have omitted many calculus-dependent proofs in favor of providing intuition. That said, there is some calculus and linear algebra in the book, but I have tried to write the text so that the algorithms and the proofs are intuitive, even if you don't understand all of the notation. Concerning programming, it is no understatement to write or to say that modern applied statistics relies 100% on programming. There is simply no way to implement statistical procedures without knowing at least a little bit of coding. Fortunately, there are well-developed coding libraries that implement the low-level details. This means that you don't need to be a professional programmer to be comfortable applying statistics, but you do need to be comfortable with coding. In this book, I use Python and R. Those are arguably the two most important languages for modern statistics. I'm pretty sure they won't always be so popular. Some other language will be developed that is better, easier, and faster. For example, the Julia programming language looks pretty promising. But the good news is that all programming languages share some similarities, so learning statistics in Python or R will help you apply statistics in any other language. In other words, learning coding is time invested, not time wasted, even if you use a different language in practice. Anyway, ChatGPT or other advanced language AI can translate into SAS, MATLAB, Julia, or any other language with pretty decent accuracy. To be clear, you do not need any coding to work through this book. You can skip all the code, you can skip all the exercises, and just focus on the conceptual and interpretational topics. But I designed this book such that a deep understanding of the material comes from working through the code and the code exercises. People learn best by seeing and doing rather than letting their eyes just bounce over the words and equations or just passively listening to this audiobook. This is a guiding philosophy of my writing and of my teaching. I have more to say about using code for this book, but let me first discuss the exercises. Section 1.5, Exercises. I'm sure you've heard this before. Math is not a spectator sport. If you simply listen to this book without solving any exercises, then sure, you'll learn something, and I hope you find the audiobook useful. But to really understand statistics, you need to solve statistics problems. I designed the exercises to require some effort and some creativity. They can be solved only through coding. So these are opportunities for you to explore concepts, visualizations, and parameters in ways that are difficult or impossible to do without code. I very strongly encourage you to work through the exercises. I mean, like super duper, really a lot encourage you to work through the exercises. They're not just busy work. They are ways for you to solidify and explore and expand your understanding of statistics in ways that are simply impossible from only reading or listening to the chapters. The exercises also provide a wealth of code that you can use to continue learning and applying statistics to your own data. I provide all of the code solutions to all of the exercises, but keep in mind that there are many correct coding solutions. The point is for you to explore and understand statistics using code. It doesn't matter if you reproduce my code or my solution exactly. Feel free to look at my code solutions as much as you like. It's not cheating, I promise. This is especially true if you are new to Python or R, and if you understand the statistics concepts but struggle with the coding syntax. Again, the purpose of the exercise is to give you opportunities to learn, explore, and expand your knowledge. They are not meant to be quantitative assessments that you pass or fail. In addition to my coding solutions, I have also created online videos in which I explain the Python code and solutions. You can find those videos on my YouTube channel, which you can find by Google searching or YouTube searching for my name, or you can see the online GitHub repository for a direct link. The GitHub repository is github.com/MikeXCohen/statistics_book. But again, it's probably easiest just to Google for it. Finally, Chapter 20 contains tables that provide brief descriptions of each exercise in each chapter. Section 1.6, Learning from Simulated Data. There are 3 traditional ways to learn statistics. One, by staring at equations in textbooks written by emeritus statistics professors, at least some of whom write these books to show off to their colleagues rather than to educate learners. This approach is great if you are interested in pure mathematical statistics, but can be intimidating if you are interested in real-world applied statistics. 2, by reading statistics books full of examples using data that are rarely made available to you and that have characteristics or on topics that are unrelated to any kind of data set or application you will ever work with. 3, by reading software tutorial books or websites to learn which menu options will implement which analyses. This approach is great if you already know the statistics and just need to learn the implementational intricacies of a particular software program, but this approach can be confusing and misleading if you don't already understand the statistics. In this book, I aim to present a modern, computational way to learn statistics by simulating data sets that have certain characteristics and then performing statistical analyses on those data. In essence, simulations provide a means to experiment with custom-tailored data sets in a virtual environment. By running many iterations, manipulating the data features, and observing the results, you can gain an understanding of how statistical analyses behave and what can be expected in real-world scenarios. A detailed set of motivations and advantages of using simulated data is provided in the beginning of Chapter 5. An analogy is working out at the gym. The machines and the free weights at the gym are weird and unnatural, but they build strength and endurance that help you in your real-world behaviors. Likewise, you may think that simulating data is weird and unnatural, but I hope, that the mathematical, conceptual, and implementational skills that simulations allow you to acquire will help you in real-world data analysis. Now, not everyone likes this approach, and I respect that there are differences in opinion and preferred learning style. But to my knowledge, there are many, many statistics books that do not rely on simulated data as a mechanism to do a deep dive into statistics, math, algorithms, and interpretations, and at least one book that does rely heavily on simulated data. That's the one you're listening to right now. I understand and respect that different people have different opinions and preferences. I promise I am not personally offended if you don't like this educational approach. Section 1.7, Using the Code with this book. This book does not include a Python or R tutorial. I have tried to make the code sufficiently commented that a beginner can understand and adapt the code to their own applications, but I do assume some basic coding familiarity. If you understand variables and for loops, functions, importing libraries, and basic plotting, then you know enough to work with the book code. If you are completely new to Python or R, then I recommend learning some coding before continuing with this book. Section 1.7.1, Which language to use. I'm not sure whether it makes sense to follow both the Python and the R code in depth. It's probably best to pick one language and maximize your time on that language. So which language should you choose? I cannot say. My advice is to focus on whatever language is used by most people in your department or company or university or whatever your context is. If you don't know which language to use, then it's probably better to focus on Python because it's a general purpose language, whereas R is more narrowly focused on statistics. Keep in mind that R and Python are different languages that use different libraries. Statistical results on the same data should converge between the two languages, but they are not guaranteed to be identical, especially for some advanced analyses that rely more on complicated mathematics. So this all means that it's best to use one language within a given project. Section 1.7.2, Following along with Python. You can use any IDE that you are most comfortable with. I wrote all of the Python code using Google's Colab service, which is free and integrates well with their other projects, including Google Drive. Therefore, I recommend using Colab to follow along with this book, especially if you are relatively new to Python. The main libraries I use are NumPy, SciPy, Pandas, StatsModels, and Matplotlib. Getting the book code into Google Colab involves 3 steps. Download the code from GitHub, upload the code to Google Drive, open the code files in Google Colab. Concerning downloading the code for this book is available at my GitHub site, that is github.com/Mike X Cohen/statistics_book. If you are comfortable with Git, then you can clone this repository to sync the files locally. If you have no idea what that previous sentence means, then don't worry. You can get all the code without knowing anything about Git and without needing to log in, sign up, give an email address, pay, or anything else. Simply go to the GitHub repository URL, look for the blue button towards the top right that says Code, Click on that button, look for a link that says download zip, and that will download one zip file that contains all of the code material that you will need for this entire book. Unpack that zip file locally on your computer. The next step is to upload the code to Google Drive. Google Drive is a free cloud-based storage service that Google provides to all of its users. You do not need to pay to use Drive, but you do need a Google account. So in a browser, go to drive.google.com. You may need to log into your Google account if you're not already logged in, and create a folder for this book. Then find the files you've downloaded onto your local computer and simply drag them onto the Drive folder to upload the files. Just note that Drive does not unpack zip files, so you will need to unzip the files on your local computer first. Now those files are stored in the cloud. That's convenient because you can access them from any internet-connected computer anywhere as long as you are logged into your Google account. In fact, you can delete the files from your local computer if they bother you for some reason. The next step is to open the files in Colab. Select a Python notebook file. They end with the extension .ipynb, and either double-click on the file or right-click on the file and select Open With, and then Google Colaboratory. That will open a new tab in your browser with that notebook file. Now, if you have absolutely no idea what you're looking at with this notebook file, then you need to learn some Python coding before continuing with this book. If you are familiar with Python, but you're new to Colab, then I think you will benefit from watching a YouTube video about using Google's Colab service. But the basic Colab interface is really easy and it won't take you long to master. It is also possible to import the files directly from my GitHub repository onto Colab through the File Open menu options. But this imports only one file at a time, so I think it's easier to upload them all at once onto your drive. A parenthetical note on paying for Google services. You can pay to upload your Drive storage limit and or to get better access to Colab servers. Paying for these services is absolutely not necessary for this book, but is something you might want to consider if you anticipate heavy usage for other applications. I recommend creating a copy of my code to modify. That way you have the original version of my code, and you can feel comfortable making whatever and as many changes as you like to your version. Of course, you can always download a fresh copy from my GitHub repository. Concerning using a different Python IDE. Using Google's Colab service will help ensure that you can reproduce all of the results and all the figures in this book. Therefore, I recommend using Colab. But you can use any other IDE on the cloud, on your local computer. Just keep in mind that some things in Python are IDE dependent and version dependent. It is possible that you may need to make some modifications to my code, for example, concerning the details of visualizations. I ask you to please understand that I cannot provide support for difficulties or errors encountered when using the code outside of the environment in which I created it. Section 1.7.3, following along with R. The R code was written in RStudio, version 2003.09.1. RStudio is free and cross-platform. You can also run R code in Google Colab, although I have not tested all the code in Colab, so I don't guarantee that it will work without modifications. You can download all the R code from the same exact GitHub repository that I mentioned already now several times. So again, that's github.com/Mike X Cohen/statistics_book. Concerning using and installing libraries, I use myriad R libraries throughout this book. They're all listed and imported at the top of each chapter's code file. If you encounter errors in R about functions not being defined, then probably you need to install the relevant libraries. Section 1.7.4, Modifying and Reposting My Code. Concerning modifying my code, yes, please do. I very much hope that you see my code not as immutable text, but as a source of inspiration for you to modify, adapt, and explore. Concerning reposting my code, I am occasionally asked whether I allow people to post my code or modifications on websites or blogs or their GitHub repository or something else similar. And my answer is yes, absolutely. Please feel free to use and share my code as you like. I only ask that you cite the code at the top of the code file. You can include the URL to the book on GitHub or a link to the book on Amazon or wherever you purchased it. It can be something as simple as the following. This code is modified from Mike X Cohen's book on statistics. For code and links to the library, see the GitHub URL, github.com/MikeXCohen/statistics_book. Concerning using other computer languages, I have zero doubt that all of the exercises and visualizations can be solved using MATLAB, SPSS, Julia, SAS, Statistica, C++, or basically any other numerical processing language that has statistics libraries. But I chose to use Python and R for this book. If you want to use another language, then that's great. However, I cannot support questions for other languages. If you would like to translate all of the book code into a different language, please contact me. I would be happy to link to your GitHub page from mine. At the time of this writing and also this reading, ChatGPT is impressive but imperfect in translating a large amount of code. Any AI translated code would need to be thoroughly, carefully, meticulously checked by a human expert before I would feel comfortable linking to it. Section 1.8, Online Resources. Concerning the online course, this book is based on an online course that I created. The book and the course are similar but not redundant. You do not need to enroll in the online course to follow along with this book, or the other way around. Some people prefer to learn from online videos, while others prefer to learn from reading, or in this case, listening to textbooks. I am trying to cater to both types of learners. Following both may be beneficial, but I want to make it clear that the two resources are specifically designed to be independent. It is not my intention to upsell you. For example, that online course is taught using MATLAB and Python. The list of topics is somewhat different between the course and the book. You can find a list of all of my online courses at my website, Sincxpress.com. That is SINCXPRESS.com. The online course is separate from the free video explanations of the exercises that accompany this book. Those videos are designed for this book and are available on my YouTube channel or via a direct link from the GitHub repository that contains the code for this book. Concerning searching for explanations. Although I have tried to write this book as a self-contained resource to master applied statistics, it is naive to think that everyone will find it to be the perfect resource that I intend it to be. Everyone learns differently, and everyone has a different way of understanding mathematical concepts. If you struggle to understand something, please do not jump to the conclusion that you're not smart enough to understand it. A simpler possibility is that the explanation that I find intuitive is not the explanation that you find intuitive. I try to give several explanations of the same concepts in hopes that you will find traction with at least one of them. And if none of those work for you, then do not hesitate to search the internet or other statistics textbooks if you need different or alternative explanations. Concerning the online code, this book has only the occasional snippet of code, and instead, all of the code, including the code to create the figures in the book and the solutions to the exercise, are available at my GitHub repository. Should I read the URL again? Maybe I will. github.com/MikeXCohen/statistics_book. The best way to learn from this book is to have the code in front of you while you read or listen to this book. You can see how these statistics concepts are implemented and how I created the figures. You can adjust the code to explore the concepts, and you can compare your exercise solutions with mine. I apologize, dear listener, for stating multiple times that the code is available online and not entirely printed in the book, but I have had quite a few experiences of people complaining that I do not make my code available, even giving my books and courses poor ratings online. I'm not angry about it because I know that those people were just so excited to learn that they rushed through the introductory material and didn't even know that the code was freely available on GitHub. Section 1.9, AI Assistance. I was about halfway through writing this book when ChatGPT 4 was released to the public. It is impossible to predict how technology will develop and impact life in the future, but deep, complex language models like ChatGPT have the potential to have a significant impact on the way that we write. Section 1.9.1, ChatGPT 4. I spent a lot of time exploring ChatGPT and considering whether it will be useful for this book. ChatGPT is a remarkably good writer, but there were 3 limitations that prevented me from really significantly incorporating it into my writing. First, several explanations that ChatGPT gave were incorrect, although the writing style was so fluid and so authoritative that it would be easy to be fooled. Second, I found ChatGPT 4's writing style to be stuffy, overly formal, and sesquipedalian. Footnote. Yes, I had to look up that word. I love the meaning, but I never remember the word itself. End footnote. ChatGPT 4 writes like a gifted teenager who consults his thesaurus too often. Third, ChatGPT equivocates and hedges, refusing to state that something is correct or incorrect, right or wrong, appropriate or inappropriate. There were perhaps a dozen sentences in this book that I really struggled with and which I asked ChatGPT to rewrite for me. In none of those cases did I take ChatGPT's suggestions verbatim, but in all of those cases, ChatGPT helped me improve the readability of those sentences. I also used ChatGPT to help implement some aspects of coding, including details of visualizations, debugging, translating Python into R, and stylizing LaTeX. It was often faster to debug with ChatGPT than to search online and spend half of my time declining cookies, clicking away pop-up ads, scrolling past irrelevant ads, and rejecting requests to join newsletters. I also used the application Writeful to check my spelling and grammar, and spell checking is basically a primitive form of AI-assisted writing. Anyway, the point is that on the cusp of what may be the era of AI writing, I can assure you that this book is fully human-written with the occasional assistance from ChatGPT to smooth out clunky sentences and help with coding issues. Section 1.9.2, Book Figures and DALL-E 2. Nearly all of the figures in this book were made with Python using code that I provide and which you can inspect, explore, and modify. Some of the figures were adjusted or fully made using Inkscape. All of the simple line drawings in the margin figures were made with assistance from DALL-E 2 at labs.openai.com. Here's how it worked. I thought up a prompt to use, and then I picked one of DALL-E 2's outputs. In many cases, I did some light editing in Inkscape to modify images or combine pieces from different images. If you have not yet delved into the world of AI-generated art, I strongly encourage you to explore it. It is visually captivating, and stimulates profound contemplation about what art means and whether it matters who or what creates it. Unfortunately for you listening, I cannot really explain the beautiful and creative margin figures that DALL-E 2 made for this book. So you will have to check the book version to see the margin figures from DALL-E 2. End of chapter 1.